Thanks for joining this episode of our webinar series on best practices in eDiscovery, AI, and digital forensics. Today's session is focused on a topic that's been in the news a lot lately: artificial intelligence advancements, and in particular, generative AI models and ChatGPT made a huge splash in 2023. They're now poised to help automate many eDiscovery tasks, and we're excited to show you how GenAI models like ChatGPT, in combination with OpenSearch technology, can help power your eDiscovery workflows and help you build better cases. My name is Jeff Fugit. I'm the Chief Revenue Officer for Lexby, and I'll be the moderator for today's event. We've got a lot of information to cover, and I'll jump right in. Our webinars take place monthly and cover a variety of relevant eDiscovery, AI, and digital forensic topics, trends, best practices, and strategies. We've got limited seating, so be sure to register early for the sessions that are of interest to you. If you have technical issues or questions, please email us at webinars@lexby.com and we'll address them right away. Our webinars are available online at lexby.com for viewing via streaming video, or downloadable as a PDF presentation or MP3 podcast. You'll find this webinar and a complete listing of other webinars at lexby.com or on our YouTube channel. If you have any questions during today's session, please enter them into the Q&A portion of the GoToWebinar console, and we'll answer them after the event. To be notified of future live and on-demand events, please email us at webinars@lexby.com or follow us on LinkedIn. For more than 18 years, Lexby's been helping legal teams handle document-intensive matters. Nearly 9,000 legal professionals have come to rely on Lexby. We have the industry's most affordable and full-featured DIY cloud-based eDiscovery platform, including integrations with ChatGPT and other generative AI models. We have the industry's fastest eDiscovery processing and document review platform. This is important because being fast means you have more time to build a stronger case. We're consistently rated as having the best customer service and support, the easiest to administer, and the easiest to do business with. We've also been rated by G2 as delivering the fastest return on investment. We have a full forensic lab staffed with Cellebrite certified forensic investigators and Axiom Magnet certified forensic investigators who perform full and targeted forensic collections and assist with evidence acquisition. If you'd like a demonstration of our platform, simply email us at sales@lexby.com and we'll get that scheduled. We've got two guest speakers today. Mitchell Sleep is a senior eDiscovery specialist at Lexby. Mitchell is certified on the Lexby eDiscovery platform and the OpenSearch capabilities. He is a former litigation paralegal with approximately 8 years of experience with a large defense law firm. He is also SED certified and has a BA from the University of Kentucky. Joining Mitchell is Erica Biller. Erica is a Lexby product manager. She is highly experienced in law firm operations and eDiscovery. She is a litigation paralegal and is also SED certified. Erica will be walking you through some specific use cases of GenAI and eDiscovery and their benefits. Before I turn it over to Mitchell and Erica, I'm going to ask for your participation in a couple of polling questions. And our first polling question is, are you currently using ChatGPT or other generative AI models in your legal practice? And while you're answering that, I'll thank you for participating in our polling questions today. All right, I'll go ahead and close that poll. And our next polling question, how do you think using ChatGPT and GenAI and eDiscovery will benefit your practice? All right, we've got a few more answers coming in. And I'll go ahead and close that poll. Thank you for participating on our polling questions. And without further ado, I'll turn it over to Mitchell Sleep. Mitchell?
Thanks, Jeff, and welcome, everyone. While many individuals see the task of search as locating data through any means possible, within eDiscovery, search is generally specific to locating documents based on searches for text, such as keywords and/or phrases. Typically, search would be specific to keywords and/or phrases appearing within a document. However, Depending on the tool being used, as well as the nature and capabilities of the search engine, search may even be applied to metadata fields. But search can have wildly different definitions, capabilities, and results, depending on the review tool and search engine being used. For the remainder of this webinar, I'm going to focus on search within the Lexby eDiscovery platform. In addition to discussing search within the Lexby eDiscovery platform, we will also be discussing how AI can be harnessed and used with search, as well as ways users can utilize AI in LEP interact with search hits. Search within the Lexby eDiscovery platform, which will be referred to from this point forward as LEP. There are several ways to quickly locate documents, and one of those is through completing searches. Search within LEP is specific to the platform's ability to locate files based on textual content placed into the search bar on the browse page. I want to be specific about what search is in LEP and where that's completed from within the platform, since LEP also provides the ability to filter on metadata, coding, and broader attributes associated with documents, which is different than search. Once searches have been completed, LEP will refine the total documents displayed on browse to only reflect the search hits, whether that is for an entire case or a filtered subsection. Once search results are returned, users are able to work with them in a variety of ways. Users can review hits individually by selecting and reviewing them. Users can use the Expand to Email Family paperclip to review those search hits plus family files. Users can begin selecting files for bulk coding through the multi-doc edit tool. Or users can begin filtering the search hits down based on metadata, coding, or broader attributes associated with the documents. Additionally, users can apply filters before running searches if needed. That way, the search results are specific to the documents within that filter criteria. In order to get a better understanding of search within LEP, let's talk about the search engine that is used and the different types of searches that can be completed. In LEP, the OpenSearch search engine allows for thorough searches to be run across an entire case or a filtered subsection using various search options. LEP searches results from OCR and native extraction, as well as an additional index for translated documents. Also, there are no noise words in OpenSearch. In addition to OpenSearch providing the ability to search for noise words, Lexby's change to OpenSearch also allowed for much faster processing. After the change to OpenSearch, processing speed in Lexby increased between 10 to 20 times. With this increased processing speed, OpenSearch allows LEP to take data from supported file types and convert it into processed data with searchable text in a fraction of the time that it used to before changing to OpenSearch. Once data is processed in LEP, users can utilize OpenSearch to complete a variety of simple and complex searches on supported file types to locate the data that is germane to the needs of the case. Different types of supported search results include the following: Boolean searches, wildcard searches, fuzzy searches, proximity searches, and metadata searches in select fields. Since search in LEP can be about as simple or as complex as one would like, let's take a look at the different search options and how they can be used in more detail. Boolean searches are made up of words and or phrases that contain connectors, such as and, or not, that indicate association. Boolean connectors, and, or not, must be capitalized. Users can run complex Boolean searches in LEP. So in the scenario that a user were running a Boolean search with and, like budget and meeting, the expected results would be for documents to be returned with both of those terms. With budget or meeting, the expected results would either contain budget and or meeting. In those scenarios, those results could potentially only have one of those terms. Not or and not would be the same sort of scenario of having one term and not that follows. When parentheses are used, that can be really important for search precision. For example, budget and meeting or application could mean budget and meeting or application, or it could mean budget and meeting or application. And then when running phrase searching, you'll want to keep those in quotes. Otherwise, if a multi-term search is run without quotes, that will be treated as a search for one word or the other. Let's look at some Boolean search examples run for a moment. Some of these are going to be depictions of those that were on the prior slide. So here's one for budget and meeting, where we see that connector is capitalized. Here's one for budget or meeting, and budget not meeting. Wildcards allow users to include special characters in search to locate unspecified text in either a single character or multi-character manner. Wildcard searches can be particularly useful when trying to limit the number of searches that are needed. Wildcards that are supported in LEP include the question mark for a single character wildcard or the asterisk for a multi-character wildcard. Let's go ahead and look at some wildcard search examples. So BU question mark we see as returning things like but or by. B question mark Y we see is going to return things like buy, buy in. BU asterisk is going to include things like budget, business, buy, burying. And BO asterisk, we're going to see returns things like Bose, Bob, book. Fuzzy searches can be used to locate words with a slight misspelling and words with a maximum of one difference, where the difference is the inclusion, removal, or replacement of a single character, or the mixing up of two adjacent characters. To run fuzzy searches, users will need to use the tilde in their search. So for example, if we were to run a search term set the tilde, expected results could contain documents with the terms sept, sen, sent, see, yet, etc. And let's look at some of these come through. So set with a tilde, we see is returning sent, or sept, set. Set with a tilde is going to return sept, net, sen, set, things of that nature. Proximity searches give users the ability to conduct searches based on an identified max distance between words and or phrases in a document, in either order. The results are considered more relevant the closer the terms are to the ordering in the search string. Proximity searches need to be formatted within quotes, followed by the tilde, with the max distance between the words and or phrases identified in number form after the tilde. Go ahead and see some proximity search examples here. So budget meeting within 3. Here's another one, budget meeting within 15. And here's one where budget and meeting are within 50. In addition to proximity searches, allowing users to locate files within a certain distance between words and or phrases, searching LAP can be much more complex than the simple examples previously provided. Users can run proximity searches with wildcards. So in the scenario of budget me asterisk within 10, the expected results would contain documents where the words met, meeting, methodology, meals, message, etc. appear within 10 words of budget. Users can also run proximity searches with wildcards and phrases. In the example here, internal with budget review as a phrase within 3, we would expect to see documents where the word internal appears within 3 words of the phrase budget review. When using phrases in a proximity search, the phrase must be in quotes and parentheses for proper formatting. Users can run proximity searches with wildcards and phrases. As we see here, an example of budget review me asterisk within 5 would have the expected documents to contain, or the return documents would be expected to have the phrase budget review appearing within 5 words of met, meet, met, meeting, methodology, etc. Users can also run proximity searches with words, wildcards, phrases, and Boolean connectors. In this secondary search example, me asterisk, guidelines or mandatory initiatives within 5 and budget would contain we would expect the documents returned contain the word met, meet, meeting, methodology, etc. appearing within 5 words of the word guidelines or the phrase mandatory initiatives, and with budget also being present in that document. Users can also run nested proximity searches with wildcards. So in this scenario, we would be looking, or the expected results would contain documents where budget and met, meet, meeting, methodology, etc. would appear within 2 words of each other, and they would also appear within 5 words of initiatives. Let's go ahead and just look at some of these prior examples run in the Mitchell training case, and we'll see how these results are going to vary quite significantly based on how these terms are being run. In this one right here, this is the internal, and then budget review within 3. And we'll look at one other one really fast. On top of users having the ability to filter for content and metadata fields in the platform, LAP also gives users the option to run searches for content and select metadata fields through the search bar on the browse page. And search in OpenSearch needs to be formatted in certain ways to achieve the desired results. Here's a table which details the search syntax needed to target the noted metadata fields. This can also be located in our help page documentation on search. We have several different search examples here, identifying different examples for metadata searches. So I'm just going to go through these quickly. In the first example, quote, budget meeting, end quote, tilde 5, and metadata type is email, we would have the expected results where documents have the term budget and meeting appearing within 5 words of each other, and where the doc type is an email. For the second example, metadata from Doug Wood and metadata to richard.shapiro@enron.com, the expected results would be where documents have the from field containing Doug Wood and the to field containing Richard Shapiro. For the third search example here, metadata / Richard Shapiro@enron.com or Doug Wood, the expected results from that would be documents where any of the metadata fields supported for search contain richard.shapiro@enron.com or Doug Wood. Users can search for dates and/or date ranges in addition to those fields that we were previously talking about. And users can complete those types of searches by entering ranges as depicted below. In order to search date ranges, users need to include a hyphen to separate the dates, enter the dates in year, month, date format, and include the word to in all caps. So in our first example, for a specific date, the expected results would be all documents with a master date of July 19th, 2022. In our second example, for a full date range, the expected results would be all documents with a master date of July 19th, 2022 through and including July 31st, 2022. In our third and final example on this slide, a partial date range, the expected results for this would be all documents with a master date of January 1st, 2022 through and including January 1st, 2023. One feature LEP has to assist with the recall of previously completed searches is search quick links. Search quick links are automatically generated after a user runs a search from Browse, and the 5 most recent are saved as links under the recent search quick links. Clicking on a link will automatically rerun the prior search. Shared quick links are those that are shared across all users in the case. There's no limit to the number of search quick links that can be created. Pinned quick links are those that can only be used by the user who created them. And recent quick links are those that are generated when users run searches. And in order for those recent search quick links to be retained beyond the 5 most recent, users will need to share or pin those that they would like to keep. Due to the way search quick links are named, the most recent search quick links will always appear at the top of the list until the quick links are renamed and/or are shared, pinned, or deleted. In addition to search quick links being a feature to assist users with search, the hit section of the document viewer is another way LEP tries to make review of search results as quick and easy as possible. When users open files from search results, LEP will automatically have the hit section displayed in the document viewer, which allows for quick identification of where the search terms are hitting within the document. There are also page hyperlinks in the hit section, which, if clicked, will allow the system to quickly pull the user to that PDF page within the document. Now that we have a better understanding of search within LEP, let's look at how AI can be harnessed and used with search. After seeing how AI can assist with development of keywords, we will display how search term reports can help with quickly seeing how those terms are hitting on documents they are being run over. Once we've looked at search term reports, we will also briefly touch on the ways that users can utilize AI in LEP to interact with search hits. In December 2023, Lexby introduced Copilot, secure integration with ChatGPT and other large language models for assistance with document review, analysis, and custom workflows. Through the use of Copilot, users have the ability to leverage AI in various ways within LEP, including generating keywords from documents, as well as analyzing and interacting with documents, including search hits. Since Copilot has a wide range of uses, seemingly only limited by the data in the case and one's mind, let's look at some of the ways it can be used with search. Within Copilot, there are several built-in prompts that users can run, with one including the ability to generate keywords. After initiating a keyword prompt under Copilot, the AI will provide a listing of keywords that users can then format for use in OpenSearch as needed. Those terms could be run from the search bar on Browse or within a search term report. Since we've already looked at completing searches from the search bar on Browse, let's look at search term reports. Search term reports in Lexby allow users to run multiple searches concurrently, and after doing so, get a report identifying the hit count, banded hit count, and unique hit count. Once the search term report processing is complete, users can also quickly locate the documents hitting for those searches and export the search term report to Excel. Search term reports are easily created and are a great tool for seeing how terms are hitting on documents in the case. Once users have formatted the terms they need to use in OpenSearch, they can be added into the report, which can be filtered or unfiltered, and then it can be run once the user is ready. Copilot allows users to interact with documents using built-in and custom prompts within the document viewer for assistance with individual document analysis. Users can run the following built-in prompts: summarize, translate, keywords, key dates, key entities and summaries, identifying personal information, and acronyms. In addition to the built-in prompts, users can also ask anything through custom prompts. Copilot also allows users to browse through the multi-doc prompt tool. Just like Copilot, within the document viewer, users can run built-in or custom prompts, only the responses will be for the document selected and not a single document. Now that we've had an opportunity to look closer at OpenSearch and Copilot within LEP, I hope it's clear why LEP is a tool that is a must add-on for the modern litigator. Not only does OpenSearch and LEP allow for significantly faster processing when compared to its prior search engine, it also gives users the ability to complete precision searches. Precision search coupled with Copilot provides users the ability to leverage tools that are viewed by many as the future of document review.
Thanks, Mitchell. Before I turn it over to Erica, I'm going to walk you through the evolution of some of the models and their performance metrics, including context window sizes, speed, and reasoning performance. With OpenAI adding $6.6 billion to their coffers in their latest round of funding, we're not expecting the innovation cycles to slow down anytime soon. Most of the advancements of each release focus on either increased capacity and speed or improved reasoning. What's impressive is that ChatGPT reached 200 million weekly active users in record time. ChatGPT reached 1 million active users within 5 days of its launch and reached 100 million users by January of 2023, which makes it the fastest growing app in history. Its latest release, GPT-o1, is more expensive and not as fast in returning results because it takes reasoning to the next level by refining its thinking, attempting different strategies, and identifying mistakes. We've also seen impressive gains from Anthropic's Claude 3.5 Sonnet model. It has a larger context window than ChatGPT and a fraction of a second slower output speed. Google Gemini Pro has an enormous context window and decent speed, but hasn't performed as well in our tests reviewing documents for responsiveness. On this slide, I'm trying to help you demystify the situation with tokens. As you can see, one page of 500 words takes approximately 667 tokens to process in a GenAI model. That means in a 128K context window, you'll be able to input approximately 195 pages of content. Here you can see how some of the different models stack up against the others in terms of context window size, estimated page counts, and output speed. There are a plethora of other models, and we'll work to keep you apprised of the latest performance benchmarks. Check our blog at lexby.com if you're interested in keeping up with these innovations. For use in eDiscovery, we found that GPT-4o and Claude 3.5 Sonnet are some of the highest performing models, and Erica will walk you through some of the use cases that we're utilizing these models for. And I'll turn it over to her to get started.
So, what are some use cases that AI can be used in for eDiscovery? The first one that we're going to touch on is determining relevancy or responsiveness. Now, we're approaching this from the perspective of utilizing generative AI to help conduct a first level review. So essentially, we've put together a prompt here, and we have a topic, and then we're asking the AI to respond yes or no. So either the document is responsive to this topic or not responsive. And then we're asking it to give a confidence rating of its assessment based on a scale of 1 to 10, with 10 being the most confident and 1 being the least confident. And we've also asked for a brief summary as to why it has made the assessment it has. And we've also specified a format for the output of its response. As you can see, the AI determined that this document was responsive to this particular topic. It had a confidence level of 9. And then it also provided us with the brief summary that we requested, and it gave us the overall response in the format that we requested as well. So when we look at this from the perspective of a first level review, imagine running this prompt across all of the documents in your data set, and then taking the documents that have a confidence level of, say, 8, 9, or 10, promoting those to the next level of review, and then maybe taking documents with a confidence level of 7 or lower, and either maybe doing some extra searches on them, or generally just putting another set of eyes on those documents before you make the determination as to whether or not you want to go ahead and promote them to the next level of review. Obviously, implementation of AI in this manner is going to substantially reduce your costs and put you significantly ahead of schedule, because we're looking at a first level review being completed in really 24 hours. The next use case that we are going to touch on is personally identifiable information, also known as PII. We have certainly all struggled at some point with having to identify it and get it redacted out of our data sets in preparation for either being used as exhibits or being produced to other parties. So sometimes we're fortunate enough that we know exactly what we're looking for with PII. We know all of the types of documents that we have and what's going to need to be redacted from them and where to find it. However, we're not always so fortunate. So you can really craft a prompt if you don't have a good grasp on what type of PII you're necessarily looking for or dealing with in your data set. You can put together a prompt and ask it, hey, what types of PII are in this group of documents? And it'll provide you with a list. Again, you can be specific if you want. You can see here in the example on the slide that we have specifically asked for email addresses, social security numbers, and phone numbers, which is precisely what it gave us. And that was off a basic patient intake form. But again, if you don't know what you're looking for, you can ask for it to provide it to you, what it believes is PII, and then you can actually go a step further and ask for it to provide it to you in a specific format. So, as we all know, phone numbers are never written in a consistent format. Area codes have parentheses around them. Sometimes they don't. Sometimes email addresses, if they've gone through processing, they'll have parentheses around them and then a name. Sometimes you've got a semicolon after it. You can write into your prompt that all of these things be normalized and then deduplicated, so you end up with a single list of the unique PII that you need to be looking for across your data set. Another great use case for using AI is to analyze financial records, so bank statements. We recently had a user who was spending an inordinate amount of time going through bank statements for multiple accounts, trying to identify, looking specifically for transfers between one account to another. And then every time they'd identify one, they went ahead and added it manually to an Excel spreadsheet, and it was tedious, and the workflow is just untenable when you have that much data to pour through. So in this instance, we recommended using AI to help with that process. So you'll see here we have 4 different synthetic bank statements. What we're going to do is we're going to select them here. And before we run this prompt, we're going to go ahead and review it real fast. So essentially, we're asking it, analyze the following bank statements and extract only the entries related to fund transfers. You want to look for keywords such as transfer, wire, ACH, deposit, withdrawal, send, receive, or any specific transaction descriptions that indicate the movement of funds between accounts. Present the extracted entries in table format using the bar character as a delimiter. The format should appear as follows. And you can see here, we want it to be date followed by the account number, the description, the amount, and then the link to the supporting document for that particular extracted data. So we are going to go ahead and run that. And while this processes, the benefit of putting this into a table format is it will come out delimited, so you can copy and paste it directly into Excel, and it will be formatted in columns that are easy to filter and sort on, and it will just make the data far more manageable and easy to work with. As you can see now, it is running through and identifying everything that we asked for. Yep. So these entries include both incoming and outgoing transfers, as well as electronic deposits and withdrawals. So if we copy what we've received here, we open up an Excel and we paste, here you go. And we can see here, we have the different mentions, the different descriptions, we have multiple accounts, amounts are in here, and then these are links or URLs back to the supporting document in the Lexview platform. So overall, a fantastic tool as far as streamlining the review or analysis of any sort of financial data. The next use case that we're going to look at is using generative AI for document translation. A lot of times we're fortunate to know on the front end during the collection phase whether or not we're going to have a large set of foreign language documents that we're going to have to contend with. With Lexview Copilot and Autopilot, we can process foreign language documents and translate them either in mass or, as we have on the slide here, on a document by document basis. A simple request or a prompt of please translate this document into English is what we used, and you can see the response that we got on the right-hand side. Again, if you know that you have a lot of foreign language documents that are going to be in your review, you can run the prompt against all of those at once. Or if you're reviewing what you think are primarily English documents, and then you happen to come across a rogue foreign language document, you can always run this on the fly just so you can go ahead, get through your review, and move on to the next document. The next use case seems to be a favorite among those that I've spoken with, and I certainly wish that it would have existed back when I was working in a law firm. That's going to be the ability to summarize hearing transcripts and deposition transcripts. Obviously, you can use AI for all sorts of summarization and document analysis, but we have certainly all been responsible at one point or another, I would imagine, with having to summarize deposition transcripts. Somebody has to do the dirty work. And so now we can have AI do it for us. So here we just, again, a very simple prompt. Please summarize this trial transcript that we have here. And that's exactly what it does. And it does it pretty quickly. And you also have the ability, if you have, say, multiple transcripts, using LexB Copilot, you can select multiple transcripts or documents that you want summarized, and it will run through and create summaries for each. It can also, if you select multiple ones, take essentially the text from all of those and build a summary of those 10 documents in aggregate. So it's something to consider. Absolutely one of the most useful aspects, I think, of AI in eDiscovery. Another great use case for AI is for analyzing and summarizing medical records. At some point, most of us have been tasked with, taking a batch of medical records and running through and generating some sort of summary that's easy to read and digestible. So you'll see here that we have 5 synthetic medical records. So we are going to run a prompt across them, and that prompt is that these documents contain medical records detailing treatment administered to a patient on specific dates. We're tasking it to extract the key details and organize them in a list based on the date of treatment. And then we're asking that if a date of treatment isn't available, that it be placed at the end of the list. We want it to identify the medical provider's name, the purpose of the visit, any diagnosed conditions, and then we also want a succinct treatment summary within 75 words, along with any prescribed medications and any mentioned medications. Then we're also asking for it to provide links to the supporting documentation for each of those entries on the list, and we're letting the AI know that your analysis, or its analysis, is going to facilitate an efficient understanding of the patient's medical history. So we're giving it a little bit of context. So we are going to run this prompt now. And as you can see, it was just, this title is actually what's generated by the AI. You can go back in and update that title to whatever you would like for it to be once it's been generated. So as you can see here, it is generating the report with the treatment summaries following, what we specified. And it also has the document links to it. And that's pretty much it. And if you click here, you just click copy. That copies all of the text here, and it also maintains the formatting. So you could paste that into, say, a Word document if you wanted, and work with it further there. Or if you're compiling a whole bunch of info into something like that, you could also use that. But yes, so medical summaries just got a lot easier. No more having to to pore over mountains of mind-numbing medical records one at a time and construct a summary, you can go ahead and just let AI do it for you. The next use case we're going to look at for generative AI and eDiscovery is going to be IDing key dates and entities. And really, this kind of gets into some early case assessment work or tools. And with generative AI and how broad its functionality is, it's really a fully customizable analytics tool. Again, this particular example is for key dates and entities, but you can really make it anything that you need. So in this particular example, we actually selected 10 documents just randomly, and then we asked it to identify the key dates as well as the key entities in those documents, and then provide us with a summary of those 10 documents as well. So again, while this is just one example of what it can do, early case assessment analytics in general, with how customizable GenAI is, really there is no limit to the kind of information that you could probably use this to generate. So the final use case is my favorite. I've saved the best for last, and that is using generative AI to create chronologies. Certainly, if you've worked in the legal field, in a law firm, whether you're an attorney or a paralegal, we have all been tasked with creating a chronology, a timeline, whether you're sifting through a few documents, looking for a few key events, or you have had a data dump and it is now your fun task to get everything in order and figure out what's actually going on. Now, instead of having to labor intensively for days and days trying to get things in order and manually creating a timeline or a chronology, you can do it literally within a minute or two. You'll see in this particular example, we used only one document. However, what's unique about it is that this document didn't have, it wasn't a document that would be used to be timelined in a sense that you would normally think of. And it actually mentions here, so we inputted our prompt, create a chronology of the key events in this document. And so it lets us know what this document is, but it also mentions that the key events and data points in the document are not events in the traditional sense, but are statistical updates and activities related to the direct access program as of specific dates. So again, it's not, these aren't dates in the traditional sense. It goes through and it timelines what are essentially these statistical updates and activities. And then to add even further context to the timeline, at the end, it states that the document does not provide specific events in a narrative form, but rather gives a snapshot of the direct access program status at the end of August 2001 and the activities related to the program within that month. So, I mean, every time I've ever created a chronology in the past, you go through diligently, create your entries and whatnot, but literally within certainly less than a minute, it spit out a chronology, and it even gave us context as to why these dates are not what you would traditionally see in a document chronology. So again, this was on one document. However, you can select however many documents you would want in the case and say, hey, create a chronology of the key events in this document, and it will go ahead and generate one for you. And that particular use case is one of my all-time favorites, and I absolutely wish that it existed back when I was working in a law firm. So just absolutely one of the biggest time savers that generative AI can provide us for use in eDiscovery.
Thanks, Erica, for walking us through those use cases. If you have any questions about use cases that we didn't cover today, you can submit them via the Q&A portion of the GoToWebinar console or submit them via the survey at the end of today's session. It's amazing how the continuously improving models are rapidly expanding the viable use cases in eDiscovery. One promising use case we're seeing is the ability to analyze opposing counsel's prior court transcripts and identify argument patterns and rebuttal strategies for trial preparation. It's great to see how GenAI can be utilized pragmatically to help lawyers and paralegals successfully handle document-intensive and more diverse cases. As I mentioned in the introduction, we have an advanced forensic lab equipped with the latest tools to help collect documents you need for your cases. We perform remote and on-site collections and have performed collections from all kinds of sources, as you can see on this partial list. If you need to find deleted text messages or collect data from sources like Slack or Microsoft Teams, then we're here to help. And that leads me to our next polling question. Do you have a digital forensic project, and would you like a complimentary consultation? All right, I'll go ahead and close that poll. We work with a lot of litigators to help them solve their eDiscovery challenges. Jordan Howlett is a sophisticated litigator running a multi-office boutique firm. Most of his cases involve larger, well-funded opposition. With Lexby, he likes having ChatGPT available at his fingertips so he can quickly gain insights into the relevant case documents. David Jones was concerned he would be outgunned by his AmLaw opposition. He quickly realized that Lexby was a great equalizer and helped him build his best case that delivered a winning verdict. Paige Tackett at Thompson Co. needed Lexby's speed to get productions out the door to meet deadlines. Lexby is lightning fast and gets you from document ingestion to productions faster. Patrick Biggins needed an easy-to-use eDiscovery platform to handle document-intensive cases. Lexby got him onboarded fast and provided the support they needed to build a strong case. With Lexby's eDiscovery platform hosted at Amazon Web Services, you get on-demand capabilities that scale to address the needs of your case. With Lexby's cloud infrastructure, you can get from document ingestion to review faster and get your productions out the door faster. All of your remote or mobile-connected employees can access the Lexby eDiscovery platform via web browser. It works great on Macs, PCs, iPhones, and Android devices. This gives you unprecedented flexibility and efficiency. I also wanted to point out that Lexby is a single end-to-end eDiscovery platform with a comprehensive GenAI feature set that is secure and doesn't limit your prompts or usage. And with that, I'll ask our last polling question. Would you like a demo of the Lexby eDiscovery platform? All right, I'll go ahead and close that poll. We'll be making the following available to webinar attendees: a recorded streaming version, an MP3 podcast, as well as a PDF. Please let us know if you have any questions or comments about this webinar or suggestions for future topics. This webinar is part of the Lexby eDiscovery webinar series. For notices of future live and on-demand webinars as part of this series, please email us at webinars@lexby.com or follow us on LinkedIn. Also, we'd like your advice regarding our webinar series. Please complete the survey at the end of today's session. Helps us continuously improve this program and cover the digital forensic and eDiscovery topics that are most relevant to you. And with that, I'd like to thank you for attending. Be sure to follow Lexby on LinkedIn and check out our YouTube channel so you'll be alerted to the latest podcasts and webinar episodes. And watch your inbox for an invite to our next webinar on best practices in eDiscovery, generative AI, and digital forensics. Take care.